Hello everyone, I am Ayush. It's been a while since I last posted. I built this robotic arm around 3 years ago. Cool project, but poor controls. Currently, the arm uses gesture control using an accelerometer mounted on my hand and two buttons. The top button controls the forward movement of the shoulder and elbow joint, and the bottom button changes the pitch and roll of the wrist. This red dial controls the rotation of the arm, and these two buttons controls the opening and closing of the jaws. This was very inefficient and painfully slow. I wanted to control this via an app, but all the apps on the Play Store only use sliders or buttons. So I built my own, which was wireless, intuitive, and could record and replay sequences on this arm. So today I'm turning this robot into a one-tap tea making robot, and we'll also try some nerve trick shots, and this can also be controlled via voice. A quick specs drop before we start. You can also watch this video which I previously made. You can watch it here from the I button. This robotic arm is a 5 degree of freedom robotic arm using 6 servo motors, one as the base, the shoulder, the elbow, the wrist pitch up and the wrist roll, and one for the gripper. The brains of this is an STM32 which sits here and a power supply which powers all of these. Most of these parts are 3D printed. Here is what I want from the app. A Bluetooth control which works every time, an inverse kinematic view so I can position the arm intuitively, and a record and replay button so that this arm can perform tasks repeatedly. So let's make an app using Flutter. So it's been about 3 days now, and here is the final app. This has an inverse kinematic visualizer where I can tap anywhere and the arm will recreate that position. Above are some sliders and this record button. In Sequencer, you can drag, rename and replay the sequences and record different positions for the arm. You can also choose different intervals and loop and play it from here. It can also be controlled by a home assistant which I have on my network. Think of this as a brain to control all smart devices. Home Assistant sends a simple MQTT command to my phone which can trigger different actions on the arm. And these commands can also be triggered via Alexa. I'll explain more details later. Let's see this arm in action. The app sends a sequence highlighted here and the robotic arm moves instantly, executing the task with precision. Alexa, make me tea.
Okay.
Here is a more in-depth look on the app. I can start by switching it to the wireless mode, which changes the mode from gestures to the wireless version. Below is the inverse kinematics view. I can tap a certain position and the arm will recreate that position. This works by identifying where I have tapped on the screen, and because I know the length of these arms, I can figure out what angles are required for each servo motor to reach that end position for the end effector. And this is known as inverse kinematics. I can also rotate the base using this curved slider like this. I can pitch up and pitch down the end effector, which is the gripper. And I can also open and close the jaws like this. I can set it to close or open. And I can change how much they have to open or close using the sliders. So I can open it more or close it more. Now for the sequence screen, which is here. This is used to record different sequences. I can start by making a new sequence. The buttons on the top allow us to create a new sequence, rename that, delete its content, and play back that sequence. Below this is an interval slider which defines what is the interval between different positions, and a loop feature which I can tap for this robot to continuously perform that motion. To record a sequence, I can say press the current record position. I can move the arm to say another position and maybe rotate it a bit. And this is position 2. I can record this position as well. I can set it to another position. Let's say this position and little below. And this is position 3. Now I can go back into the sequences. And here I have all these sequences. Now I'll play the sequence. You can see the current position, which is highlighted. I can also do this in loop and set the interval as 1 second. And you can see the current highlighted position. And from here I can stop. The cards can also be reordered and copied. I can copy it using this button, and then I can reorder by dragging it below. You'll notice some joint values are in white and some are in grey. The white values are the ones that have changed and are sent to the arm. The grey values are the ones which have not changed and are not sent to the arm. And here is a quick code tour. First, the models. The arm pose stores 6 joint values plus an optional duration, while the arm sequence is just a named list for those poses. The inverse kinematics layer lives in anchor and bone, and their solve call uses law of cosine to work out the shoulder angles and elbow angles and pushes the result into a shared joint angles array. On Bluetooth side, a helper in led.dart wraps each value into packets from S1 to S6. So you'll see strings like S3:160E, which means 160 angle is sent to S3. This is then debounced and streamed to Flutter Bluetooth serial. The sequence player walks the list, compares each pose to the previous one, and only transmit the joints which have actually changed, obeying either a global interval or per pose duration. Persistence is handled by sequence repo, which saves everything in a JSON format and remembers whichever sequence you've last selected. And finally, the UI, the main page that shows inverse kinematic canvas plus the base, wrist, and gripper controls, while the sequence player lets you reorder, duplicate, delete, and clear poses and highlight which one is currently playing. So what's next? I want to add trajectory planning into this. So I don't just send the end points like I am doing right now, and also send in between points, which would enable me to have a smoother motion. I also want to implement a pressure sensor on the gripper, which will allow me to precisely pick up objects. If you have any other ideas, you can drop it in the comments below. If you want to check out the code or more about inverse kinematics, you can check out the description below. And if this gave you build energy, drop a like and share it with someone who loves robotics. Until next time, happy tinkering.